Okay, so we're going to talk about percent yield today and what it is and how we work with it. Okay, it's exactly what it sounds like, right? Yield is how much you get, and then percent is how much you get, the percentage of what you got. So far, what we've been assuming with all of our problems is that if I put in what I put in, then I should get out what I'm supposed to. Well, the reality is that it doesn't always happen. We don't always get out what we're supposed to. So this is a way for us to describe how close we were, what we got was to what we were supposed to get. Now, some reactions have a very high percent yield, and we expect to get very high percent yields. Some reactions are actually really terrible. The reactions that make your medication have terrible percent yields, and they just can't do anything about it, which is part of why medications can be so expensive. Okay, so the equation that we use, right, like any other percentage, a percent yield is an actual yield over a theoretical yield. Okay, this is going to be very similar to finding a percent error, except that in error we were aiming for a small number, right? You want to have as little error as you can, but we want to have as much yield as we can. So we don't have the subtraction up here at the top. Just this is the actual yield over our theoretical yield. So what do those words mean? Well, actual is pretty self-explanatory, and actual yield is what you actually got from an experiment. So these are no longer hypothetical problems. Okay, they have to have an actual experiment that goes behind them, even if it's a pretend one. Okay, so when we see the problem worded out, it will always be more past tense. Everything we've done up to this point is usually worded as a hypothetical. If I do this, what will I get? Well, this is more of a I did this. What is my percent yield? And that'll be convenient too, that we'll actually ask for that. Okay, our theoretical is what you were supposed to get. Well, how do we figure that out? How do you know what you were supposed to get? And frankly, that is our calculated. That's a calculated value. We have to work through that and figure that out for ourselves. Okay, so what does a question look like? Okay, it's going to be worded kind of like that. When I started to write it as theoretical and I had to change that out. So when I reacted 28.4 milliliters of 0.8 molar calcium chloride with excess silver nitrate, I got 4.7 grams of silver chloride. And I've given you the reaction for that up here, so we don't have to do that. And then the question will always say, what is my percent yield? Percent yield problems are really, really easy to identify because they will literally ask for the percent yield at the end of the question. So how do we get that answer? Well, I'm going to need an actual yield and a theoretical yield. What we actually got from the experiment is going to be in the question. That's this right here. This 4.7 grams of silver chloride, that is my actual yield because I really got 4.7 grams. Okay, what is my theoretical? Well, I need to calculate that from my initial value. So now we pretend like there was an if. If we react to this 28.4 milliliters of 0.8 calcium chloride with the word excess means that this is not our limiting reagent. Okay, so what should we have gotten? Well, this is a stoichiometry problem, just like we've been doing all along. So I'm going to take that 28.4 milliliters of 0.8 molar calcium chloride. Okay, we're going to put it into our dimensional analysis. Now, if you're still struggling with these molar ones, that's why I put this one in here, right? Milliliters can't go in. They've got to be in liters. So I've moved my decimal point over 3 spaces. 1, 2, 3. Got 0.0284 liters. Okay. When we try to get out of these liters, because it's liters of a solution, so we do not use the 22.4. Okay, this molarity right here is our conversion factor, and it's 0.8 moles per 1 liter. So that's how we put that in, 0.8 moles per 1 liter. Okay, and then my liters of calcium chloride cancel. I'm left with moles. I move moles here, and then I'm going to go to moles of silver chloride here. Well, that's back up here, right? 1 mole of calcium chloride will give me 2 moles of silver chloride. Okay, and then, so my moles of calcium chloride cancel. I bring my moles of silver chloride down, and I find the molar mass of silver chloride. It goes up here. I multiply everything across the top, and we should come out to 6.51 grams of silver chloride. Okay, that's my theoretical. Okay, so now all I have to do is this, right? But you guys know me well enough, right, that we can't just start shoving things in. So you write out your equation, make sure that write out your equation with words first. You can abbreviate, that's fine. Okay, we put our numbers in here, and then I get 72.2%. Now, you're not gonna get 72.2 when you put these numbers in your calculator. You're gonna get 0.722, right? Because just like any other percentage, there's an implied times 100% here. And if you need to write that in, that's fine. I don't generally do it. I generally remember that I can multiply, that I can take, I'm going to end up with a decimal, and then I can multiply that to get my percentage. Okay, so running back through this, how we got here. When you're given the information, you know it's a percent yield because it actually asks. Okay, you're going to be given two numbers. One of them is a reactant that tells you how much is something we put in, right? This is my reactant. One of them is going to be a product that says I actually got this out, and this is going to be worded not hypothetically, but as a past tense thing. I did this. What is my percent yield? Okay. The product that you're given, that is your actual yield. That's how much it made. You're going to take your reactant quantity, and you're going to stoichiometry it out to tell you how much you should have gotten. That's your theoretical yield. And then you will take your actual divided by your theoretical times 100%. Will give you your percentage. Notice that I don't put a substance here because it's a percent yield, right? This is it doesn't specifically apply anymore to the silver chloride. Okay, thank you.